Hello guys, and welcome once more to this new video on my YouTube channel. So today we are simply continue by solving the commodity examination pure mathematics mechanics paper 3. So today we are going to be solving question 7 of June 2022. Actually, that is June 2022, question 7, pure mathematics with mechanics paper 3. Actually, the question reads: figure 1 shows a uniform lamina in the form of a trapezium where QR, that is where QR is equals to RS, is equals to 5A, and TQ equals 3A. A part of the question says find the distances from PS and PQ of the center of mass of the lamina. Then question 7b reads: calculate the tangent of the angle the HPS makes with the vertical. Let us then actually move into the solution of this question actually. So the part of the question is asking us to find the distances from PS and PQ of the center of mass of the lamina actually. So you have to represent the lamina, so that the lamina was represented to us as such actually. We can clearly see that this lamina actually, that's the uniform lamina, consists of a rectangle and a right angle triangle actually. Yes. So actually the question is asking us actually to get the distances from PS and PQ of the center of mass of the lamina. Actually we are going to represent those distances to be X bar and Y bar, where X bar actually is the distance, okay, from PS of the center of mass on the lamina, and Y bar will be the distance from PQ of the center of mass of the lamina actually. Yes. So to do this actually you have to come out with a table. Actually this table will help us actually to easily get this value of X bar and Y bar actually. But before coming out with this table, we have first of all to make a very big assumption, that is, let gamma be the weight per unit area of the lamina. Why am I saying this? Because this figure actually, that is a rectangle and a triangle, are two-dimensional objects. That is a rectangle is a two-dimensional object, and this right angle triangle is also a two-dimensional object actually. So then coming out with that table, this table consists of what? This table consists of the portion, that is, it consists of a rectangle and a right angle triangle. It consists of the corresponding areas actually. So this table will consist of the portion, that is the rectangle and the right angle triangle, then their corresponding areas and their weights, then the distance from PS, that is the distance of a given portion, okay, that is the distance from, for example, the distance of the rectangle, okay, from PS, and the distance of the right angle triangle from PS. We also consider actually the distance from PQ, okay, of the different portions, that is the distance from PQ of the rectangle and the distance from PQ of the right angle triangle actually. So the first portion we have a rectangle actually, that is the rectangle PSRC actually. The area of this rectangle actually, we know that the formula to find the area of a rectangle is actually length times the width. We have the length, which is 5A, but we don't have the width actually. We have to determine the width. How can we then determine that width? By simply using the Pythagoras theorem, because we have the base and we have the adjacent sides and we have the hypotenuse. So we can easily get the opposite which is actually the width of this rectangle actually. So doing this, that's obtaining the width is actually what? This 5A squared minus 3A squared, all that square root. We get actually the width to be equals to 25A squared minus 9A squared actually, from which, further simplifying, we are going to obtain the width to be the square root of 16A squared, from which we therefore obtain the width actually to be 4A actually, that is this width, that we can therefore represent that width, that is 4A on our lamina actually. Yes, so this is actually the width of the rectangle. Since we have the width of the rectangle, we have its length, we can therefore calculate its area actually, the area which is actually the length times width actually, that is 5A times 4A, which gives us actually 20A squared. The weight actually, we are simply going to multiply this value, that is 20A squared, then times this gamma, okay, which we assumed that was the weight per unit area of the lamina actually. So the weight of this rectangle is actually going to be equal to 20A squared gamma. The next thing which we need to find is actually the distance, okay, of the rectangle PSR from PS actually. So to do this, we have first of all to represent this small diagram, that is this distance, the distance from PS is actually for this rectangle PSRT is this distance which are denoted x1 actually. That is the distance of the rectangle, okay, from PS, and it is actually x1. And we can clearly say that this x1 is actually 5a divided by 2. That is the half length. That is the half of the length, which is 5 actually. That is 5a divided by 2 actually. Yes. So knowing already the distance from PS actually, which is 5a divided by 2, we can then come out. This is inside our table actually. That is the distance from PS of the rectangle PSRT is going to be 5, okay, a divided by 2 actually. Then what about the distance from PQ? Distance from PQ we are going to note it as y1 actually. What is there for that distance? The distance is simply going to be the same procedure as we use for the distance from PS. That is the distance from PQ, which is y1, we simply going to be what is simply going to be this 4a divided by 2. That is the width divided by 2 actually. Yes, which gives us actually 2a. You can therefore come and fill our table by putting the distance from PQ, which is y1, okay, of the rectangle PSRT to be actually 2a actually. Yes. So the next portion is actually our triangle, and this triangle is triangle TRQ actually. Yes. So the area actually of this triangle actually, simply we apply the formula to get the area of the triangle actually, which is what? Half base times height actually. Applying that formula, we're going to obtain the area of the triangle to be half base, the base which is 3a, then times the height which is actually 4a. We know that what 3a times 4a gives us 12a squared, okay, then divided by 2, which gives us 6a squared. So the area of triangle TRQ is actually equals to 6a squared actually. So, moving forward, that is the weight actually of the triangle TRQ is simply going to be 6a squared then gamma. So 6a squared then times gamma, which gives us 6a squared gamma actually. Yes. The next thing is actually the distance, okay, of this triangle TRQ from PS actually. To do this, we have also to come out with a small sketch actually, as we did. That is the same procedure as we did for this rectangle PSRT. But in this case, we are okay on the triangle TRQ. That is the distance from PS of triangle TRQ. So that distance actually XA plus XB, because the center of mass of that triangle is this small dot actually. So if we want to determine the distance from PS of this triangle, actually we have to add these two distances, that is XB then plus XA actually. Yes, where XA is actually the length of the rectangle simply. Yes. So determining the value of XA and XB and then adding the two will enable us to get the distance from PS of triangle TRQ simply. Yes. So let us call that, okay, that distance x2. That is x2 is going to be XA plus XB actually. What is therefore x and what is XB? XA is actually 5a, which is the length of the rectangle, and then XB is 1/3. Okay, XB is 1/3 of RQ. These are okay, and this Q. So XB is 1/3 of RQ. Actually, yes. So we know that RQ is what? RQ is actually given to us, okay, to be 3a. So replacing the values of RQ, replacing the value of RQ, we are going to get x2 to be equals to 5a, which is the length, that is XA, which is 5a, which is the length of the rectangle, then plus 1/3 RQ, which is actually 3a, actually, yes. So we get therefore x2, that is the distance from PS of the triangle TRQ, to be actually 6a actually, from which you can therefore come and fill in our given table. Yes. So what about the distance from PQ of triangle TRQ actually? The distance from PQ actually of triangle, the distance from PQ of triangle TRQ, we are going to denote it as y2 actually. Let us call that actually y2. And what is y2 therefore? Y2 is simply what? Y2 is going to be 1/3 of PS. That is, this y2 is going to be 1/3 of this distance, which is actually the distance PS. So y2 is 1/3 PS actually. Yes. So this is a given property actually. Yes. So substituting the value of PS, which is actually 4a, we are going to get therefore the value of y2 to be 1/3 times 4a. 1/3 times 4a gives us 4a divided by 3, from which we can therefore substitute it into our table actually properly. Yes. So we have already gotten the distance, okay, from PS, okay, of rectangle PSRT, the distance from PS of triangle TRQ, the distance from PQ of rectangle PSRT, and the distance from PQ of triangle TRQ. Actually, yes. So what next? We have to fill the remaining boxes, actually the remaining, okay, gaps which are here inside our table. So we have to consider therefore the whole lamina in this case, because this is our interest. Actually, we need to determine x bar and y bar, actually, and that's actually for the whole lamina, like the distance from PS, okay, of our lamina, that's of our uniform lamina, okay, which is noted as x bar, and the distance from PQ, okay, of our whole lamina, which are denoted actually as y bar, actually, yes. So to get the area of the whole lamina, we simply need to add the two areas, that's the area of the rectangle PSRT and plus the area of the triangle TRQ, actually. Adding the two, we are going to obtain 26a squared, that is 20a squared plus 6a squared, actually. The adding the corresponding weight as well, we are going to obtain 6a squared, okay, then gamma, and the distance from PS of our lamina, okay, is going to be x bar, as I denoted here into this diagram, and that is what we need to find, actually. That is the distance from PS, okay, of the center of mass of the lamina, which I denoted actually as x bar, which is what we have to look for, actually. For that is we have to look for, that is the distance from PS, okay, of the center of mass of the lamina. Similarly, the distance, okay, from PQ of the center of mass of the lamina is simply this y bar, okay, which we are going to come and represent it into our table. That is, y bar is going to be the distance from PQ, which is actually y bar from this diagram, which we can clearly see here properly, actually. Okay, of course, as I said, we are then going to determine the values of x bar and y bar, okay, knowing that actually x bar, okay, is the distance from PS of the center of mass of the lamina, and y bar is the distance from PQ of the center of mass of the lamina, actually, yes. So what then can we do in order for us to determine the values of x bar and y bar? To do that, actually, let us first of all start by determining the value of x bar, actually. To determine the value of x bar, we simply need to take the moment, okay, about PS, actually. So taking the moment about PS, we are going to obtain what? We are going to obtain that the weight actually of the rectangle, okay, that is the weight of rectangle PSRT, which is 20a squared, then times the distance of this rectangle PSRT from PS, which is 5a divided by 2. That is the weight of the rectangle PSRT, which is 20a squared gamma, okay, then times 5 divided by 2, okay, a, which is actually the distance from PS of rectangle PSRT, then plus the weight of triangle TRQ, which is 6a squared, then times the distance from PS of triangle TRQ, actually, which is actually 6a, to be equals to the weight of the whole lamina, actually the weight of the whole body, that is the weight of the lamina, okay, which is actually 6a squared, okay, gamma, okay, yes, then times x bar, actually, yes, then times x bar, which is what? Is the distance, okay, from PS of the center of mass of the lamina, actually, yes, from which we can therefore determine the value of x bar from here, which is actually what? The distance, okay, from PS of the center of mass of the lamina, actually, yes. So simplifying this, we are going to obtain 50a plus 36a to be equals to 26x bar, because this a squared gamma is common all through, so we can just cancel all of them. After that is a squared gamma is here, a squared gamma is here, and a squared gamma is here. Both all of them can just, okay, cancel, actually, for us to remain with 50a plus 36a to be equal to 26x bar, actually. Simplifying furthermore, we are going to obtain 86a to be equal to 26x bar, actually, from which we therefore get the value of x bar to be 43a divided by 13. Getting also the value of y bar, that is the distance from PQ of the center of mass of the lamina, actually, we get what? We get actually, okay, what are we going to do? We are going to take moment, okay, in order for us to get the value of y bar, okay, we are going to take moment about PQ, actually. Okay, yes. So taking a moment about PQ, in order for us to determine y bar, what are we going to obtain? We are going to obtain actually the weight of rectangle PSR, that is 20a squared gamma, then times 2a, that is the distance of rectangle PSRT, okay, from PQ, which is actually 2a, then plus the weight of triangle TRQ, which is actually 6a squared gamma, okay, then times what? Times the distance from PQ of triangle TRQ, which is actually 4a divided by 3, actually, yes, it is equals to the weight actually of the whole body, that is the weight of the lamina, which is 20a squared gamma, then times y bar, actually, which is what? Y bar, which is the distance from PQ of the center of mass of the lamina, actually. Simplifying furthermore, okay, this expression, we are going to obtain 40a plus 8a to be equal to 26 y bar, actually, yes. So simplifying also furthermore, that is 40a plus 8a gives us 48a to be equal to 26 y bar, actually. Once you get the value of y bar to be equal to 24a divided by 13. Actually, this x bar and y bar, as I explained, x bar is a distance from PS, okay, of the center of mass of lamina, and y bar is the distance from PQ, okay, of the center of mass of the lamina, actually. For which you can therefore conclude that the distance from PS of the lamina, okay, that's the distance from PS, okay, of the center of mass of the lamina is equals to x bar, okay, which is actually equals to what? 43a divided by 13, and the distance, okay, from PQ of the center of mass of the lamina is equals to y bar, which is actually equals to 24a divided by 13, actually, which actually answers the A part of the question. That is the A part of question 7, actually, yes. So the B part of the question says, actually, that is the B part of question 7 says, if the lamina is freely suspended from S, calculate the tangent of the angle the HPS makes with the vertical. So to do this, we first of all need actually to come out first of all with our lamina in question, actually, yes. So we need to identify actually the center of mass of our lamina, which is J. Let's talk about J in this case, and we need to actually represent actually what? The distance, okay, of the center of mass of the distance, okay, from PS of the center of mass of the lamina, okay, and the distance, okay, y bar, okay, and the distance y bar, which is what? The distance, okay, the distance of the center of mass of the lamina, okay, from the distance, okay, from PQ of the center of mass of the lamina, actually, which is actually y bar. We are being told that we are being asked to calculate the tangent of the angle the HPS makes with the vertical, actually. This actually, okay, if the lamina, say if the lamina is freely suspended from S, that is from this H, the lamina is suspended from this H, we have to calculate the tangent of the angle the HPS mixed with the vertical. So representing that, we are going to obtain this scenario, that is the HPS, which is this H, mixed with the vertical, that is this actually the vertical, actually. You have to take note of that, very important. If we talked about the horizontal in this case, we have actually, if okay, we are talking about the horizontal, we not have represented this angle here. But since we are being asked to calculate tangent of the angle the HPS, which is this H, mixed with the vertical, we have included therefore this angle to be actually this angle theta, which is where it is, okay, where it is there, that is theta, the angle theta, actually, yes. So what are we going to do here, actually? Because we are being asked to calculate the tangent of the angle, that is tan of theta, actually. Remember, tangent is what? Opposite divided by adjacent. Opposite in this case is x bar, and adjacent is actually equals to b, actually. From which you can therefore write that tan theta equals x bar divided by b, actually, yes. We already have the value of x bar, but what is there for the value of b? The value of b is what? Is actually PS then minus y bar. Okay, yes. So b is actually PS minus y bar, actually, yes. So doing that, we are going to obtain tan theta to be equals to x bar divided by PS minus y bar. PS, which is what? PS, which we already know the distance, which is actually the width of the rectangle, okay, and y bar, which we have already determined. Putting, okay, the value of x bar, PS and y bar, we are going to obtain tan theta to be equals to x bar, which is 43a divided by 13. From here we got the it perfectly. Then ps is actually what? The width of the rectangle, which is actually what? 4a. Then minus y bar, which is 24a divided by 13. From which we therefore get the tangent of the angle, the hps mixed with the vertical, to be 43 divided by 28, which is actually what's being asked for us to determine actually the b part of the question actually. So thank you very much for watching this video. Okay, please, I will like you to share the YouTube video if you like it. So share, comment, and don't forget to subscribe, so you channel, so that once you are going to have a notifier as well, so that once you are going to have a new video, you can benefit from it actually. Yes, so thank you very much for watching the video, and remain tuned for a very next interesting video concerning mechanics. Thank you very much, and see you.